Hello, I'm Anna Mackay and this is the second video on probability density functions. Here are some of the properties, the statistical properties. Not going to go into too much detail here because we're going to put them into practice in an example. So for a continuous random variable x with the probability function, density function on the domain A to B, we've got a mode, a median, a mean, variance and a standard deviation here. The median, I'll just point out, is equal to a half, which you would expect because that's one that's halfway along, as opposed to what the mean is. Let's compare this to the work that we've previously done in discrete random variables. You can see some similarities between the means and each of the sections. So having a look at the mean, the expected value that you would have was the sum of the probabilities multiplied by the x values. Have a look over here, there's that x, a factor of x there, multiplied by the function, but this time we're having the integral of that. And some similarities here between the variance, where there's subtracting off the mean squared each time, and that the standard deviation is the square root of that. Let's put that into practice. I'm going to use the example that I used in the previous video here and build on that. So if we have a probability density function, here's our function and it's in this domain, we have to check that it's a PDF function. So I did that in the other video, but I'm going to do it again here. How do we do that? We have to check that the area under that curve is equal to 1. So mathematically, what we write out is our integral function. Then we are going to integrate that function. Now that constant, the 1 on 24, we can just leave like this, and we're going to raise the power by 1 and put it over the power. Same with that single 1, becomes an x, square brackets between 1 and 4. I'll integrate that one by hand just to show you once. I'm actually going to bring the factor of 1 on 24 right out the front of everything. Then first of all, where I see an x, I'm going to sub in a 4. And then subtracting off where you substitute in the 1. And if you calculate that, you'll get the answer of 1. So in a minute, we're going to look at the mode, the median and the mean here, and the variance and the standard deviation. Before we do that, let's create a visual for this function. So if you haven't watched the other video, you can see what it looks like. So graphics calculator is handy. So we're in graph mode here. I've typed in the function and the domain, the view window. You might start with a standard, but it said between 1 and 4. I like to go one either side of that, so I'm going 0 to 5 with a scale of 1. And for y, I'll tell you, just go from 0 to 1 should be fine. And we'll draw that, and here's our function. The first part was to check that it was a probability density function, which means that the area under the curve between 1 and 4 will be 1. So what we're doing here is we're going to check that, and it's asking for our lower limit value of 1, our upper limit value of 4. Ta-da! As you can see here, the area under that curve is 1, so yes, it is a PDF function. The next step we're going to work out here is the mode. So the mode is the value of x which maximizes in that domain. Usually the mode would be the data value that happens the most, but what does that mean in this graph, in this function setting? It actually means the one that is the highest, the maximum one, because that's the one that happens the most. So visually that is a maximum. It's not going to be a classic maximum though in this equation. So in this function here, what's the maximum value? We can see that it's at the far end of the domain point, it's at 4. So let's work out, I'm going shift trace, subbing in an x value of 4, and we get 0.708. So that's our maximum value. So for this question here, we're going to write down that our mode is 0.708. We did that with our calculator, or algebraically, it's the function at 4. So when x is equal to 4, you substitute that number in to get 17 on 24, which is approximately equal to 0.708. So you can see why you need to have that visual to see what value you would substitute in for the mode. Next, we're doing the median. Now think about what a median is. If you had data values and you line them all up in order heights or something like that, the median is just the one that's physically in the middle. It's not where you take the classic average, add them all up, divide by how many's there. It's just the one that sits right in the middle. Now what would that mean for that graph that we had? I can't encourage you often enough to have the picture, see what that would look like. What would the middle one be here? Where would that roughly happen? So if we've got 1 at the bottom end here and 4, what answer might you expect for where the middle would be? Let's work it out mathematically. So as the expression there implies, we have to work out the integral between the lower end point, which for us is 1, and we don't know what our m is. That's what we're solving for. We write out our function, and we want to know at what point in time that's equal to a half. So when we've cumulated up to a half of the variables that have happened, half of the data, that's happened. So algebraically here, we have to integrate this. So this is where we use square brackets, put the 1 on 24 there, we raise the power, put it over the power, and that 1 turns into an x, and we're using m and 1 and finding when that's equal to a half. Now I'm going to substitute in the m and the 1. I'm going to take out the 1 on 24 out the front because you can do that with these coefficient constants for integration. Substituting in the m and then subtracting off where I substitute in the 1 equal to a half. Now I'm going to divide through by that 1 on 24 over to here and start to tidy up a little, working out these numbers here. Now essentially I'm solving for m, so I'm going to multiply through by 3 and that's going to turn this 12 into 36. Also don't forget that that term there of the m needs to be multiplied through by 3 every single term, not just the ones that have the denominator of 3. You need to make the right hand side equal to 0 so that you can essentially use the null factor law. And solving for m. We're going to go to our calculators in a minute. I'll tell you that the answer is 3.128. Let's go and solve that with our calculators and remember this. So I hope you've got this written down with the m cubed. The menu that we're going to use is the equation menu. So menu A in Casio, we are doing a polynomial with degree 3 and we put in the coefficients. Now, when I was practicing this, I made mistakes. We have m cubed, so the coefficient is 1. Was there an m squared value? No, there wasn't. So you leave that one as 0. Don't put in the 3 here just because that's the next one along. You have to make sure you're putting the coefficients in correctly. So we have a 0 here, then the coefficient of m is 3, and the constant one is negative 40. Solving, and there's that answer that I said before, 3.128. Let's have a look at that graphically. Try and build in as many checks as you can as you're doing tests and exams so that you know along the way if you're right. So if the area under the curve between 1 and 3.128 is a half, then we're right, then we've found our median. So our lower value is 1, our upper bound is 3.128, and we're going to hope that that gives us a half. Yes, to 3 significant figures it would. So now you know you've got the right answer before you even do anything else. So that's the median. What about the mean? Just while we're here, what would the mean be? So that is the statistical average for all of these values. So if there's our endpoint of 4, do you think the mean would be more or less than this number? The median is 3.128. Do you think the mean is going to be a lower number than that or a higher number? Let's check it. So for our mean here, let's write our integral expression between 1 and 4. And this time around, you'll notice there's a factor of x here. So we write an extra x and next to our function. Now you might ask yourself, do I do this by hand or do I use my calculator? In South Australia, in tests and exams, you'll be asked questions where you definitely have to use algebra, or show it by hand to find exact values. Somewhere you definitely have to use your calculator, and we will put questions in where you can only solve it using technology. And then there are some that you have to discern the use of a calculator or doing it by hand. This is one that you could do by hand. Check the marking scheme. If it's only worth 1 or 2 marks, the first mark is probably for setting up the expression and then the second mark's for the answer. So some of these ones will be too hard to do by hand. Currently, the way this looks, it looks like a product rule, which we don't have skills at the Year 12 level for integrating product rules. What you could do is expand in this X and integrate term by term. That would be fine. That might be something you do to check to see if your technology answer is correct. I'm just going to leave this with technology, and so you could put that in your run mode. As a side note, now you would never write this down, but I'm just going to show you what we would write in. Into our run mode, we can put X and keep Y1 Because you've already entered y1 into the graph mode, it will give you the answer. I will tell you now that the answer for this is 2.969, but I'm also going to keep it exact of 95 on 32. Let's check that in our calculators. Now this one we can't actually do in graph because it's got that extra factor of x, but we can do it here in run. So we're going to F4 calculate, finding the integral sign, here it was, F4. Now I'm going to type in that x. Because it's already in y1, let's use that. We're going to vars, which is variables. You're putting in y and typing 1, and then you're putting in your domain, well, your endpoints, lower and upper bounds, 1 to 4. And our answer, as I said, was 95 on 32, or 2.969. Please leave it exact as long as possible because it will keep further answers more accurate. And in comparison to the median, is this number bigger or smaller? It's smaller, and that's hopefully what you would have expected. So it's slightly to the left of the median for this question. And finishing up here, we're doing the variance. So let's write out the expression with what we've got. So we're writing our integral sign between 1 and 4, and notice that the function for variance has an x squared, and you put that next to the function. I'm going to keep my brackets so we can see what's what. And then it's dx, and subtract off the mean squared. Now the mean, as we worked out before, using the exact answer was 95 on 32, use brackets for the square there. Now again, you could do this by hand, but this is probably one that you would use technology for. A couple of points to note is technically the integration stops there. How do I know that? The dx, that ends the integration. So we're not integrating the value of the mean here. That's a number that's subtracted off after. Again, you could use this second version, you'll get the same answer. I find it's easier to just attach the subtraction of the mean on at the end as opposed to integrating it into that expression there, but it's totally up to you. I am just going to do a side note and tell you and explain what that would be integrated. So I'll just put a squiggly line here, and off to the side, the integral of that, if you want to do it by hand for practice, you need to incorporate that x squared. So it becomes x to the power of 4 plus x squared dx. And that's what you're integrating. So you raise that power by 1, so x to the 5 on 5 plus x to the 3 on 3. And you would integrate that. And the mathematical answer for that, between the bounds of 1 and 4, is 47 on 5. And then we're subtracting off that mean number squared. And our final answer is, as exact and as a fraction, 0.587. So that's the variance. And the last one here, the standard deviation, hopefully you recognise what's under the square root sign there is the square root of the variance. So we take that number, use the fraction or the decimal. The square root of that is 0.766. What that means, it's a little bit more complex because it's not a bell curve, a standard normal curve. At this point in time, we're just practicing some of these skills so that we can expand our knowledge on them a little bit later. So bear with us. The next video in this series will be a combination of 8C and 8D, looking at the normal distribution and using our calculators to work out the probabilities. Thank you.